Okay, here's our second video for today. I'm going to solve 3 questions from your homework step by step. The first question is on population growth. Okay, this was question number 1 on the front side of the worksheet. In the question it says, okay, the population of the United States has been increasing at an average rate of 0.8%. If the population was about 321.4 million in 2008, predict the population in 2020. Okay, so for this question, we can see that it's a growth question. The rate of increase, or the rate of growth is 0.8%. We're going to change that to a decimal, which is 0.008. The original amount was this, and the time is between 2020 and 2008. The rate that they gave was a rate that they calculated back then. Okay, and they want to see if it keeps growing at this rate, what will be the population in 2020. So the time that elapsed is 12 years. The equation we're going to use is y equals a times 1 plus r raised to the t. So when we fill in those numbers, when we substitute them in, y is equal to 321,400,000 multiplied by 1 plus, and the rate is 0.008, and the number of years is 12. Okay, now I'm not going to write this number again, so just know that that's the a, this number. And then this is the part we have to figure out first. So first, let's add these two together, and you get 1.008. You're going to raise that to the 12th power. You will use a calculator for this part. Okay, so if you don't remember how to use a calculator to do that, here it is. So if I have 1.008 as my 0.008, okay, and then I'm going to raise that to a certain power. I use this key, I press that, and then I enter 12 for 12 years, and then press answer, equal. So this is the rate that this is what I'm going to be multiplying this number with. Okay, so I'm going to multiply that with 321,400,000, and that will give me the new population, 353,648,856. Now in your calculator it will have a 0.2, but we're going to drop that, okay, because you can have 0.2 of a person. So that is the estimated population of the United States after 12 years, okay, in 2020, which is where we're at now. However, I looked it up, and it says that the actual population of the U.S. today is a little less than that. We projected there will be about 353 million. Right now it's about 330 million, and that is because the growth rate has decreased. Whereas in 2005, okay, when it's closer to the time when this problem was first given, okay, in 2008, back then the growth rate was about 0.93. Okay, the problem had it at about 0.8, so very close. If it was growing at that rate, okay, it would have reached this much by now. But the rate has decreased. Actually, since 2015, the rate has been decreasing, so where the annual growth rate has been somewhere between these two figures, and they're all below 0.8%. That's why the current population is actually not what this problem projected. Okay, the next question is on investments. It's also a growth question, and this is number 4 in your worksheet. Okay, so number 4, this one. Okay, the one on appreciation. I'm trying to not show you the answer yet. Okay, the investment problem uses this formula. A is the balance in your account. P is the original amount that was invested, times 1 plus R over N. R is the annual interest rate. N is the number of times that the interest is being compounded or being calculated and given to the customer, okay, by the bank. And then you raise that to the NT, N times T. N is the number of times, the same N here, and T is the number of years. In this question, the original amount was $100,000 US dollars. The rate was 5.2%, okay, that was the annual interest rate. And this says that it's being compounded quarterly. Quarterly means 4 times a year. So your N is 4, okay? The T is 12 years. So when you plug those numbers in, A is equal to 100,000 times 1 plus 0.052. 0.052 is for the 5.2%. Divided by 4, 4 is the N, which is quarterly. And then 4 times 12, which is 48. So now I'm going to calculate this with my calculator, and I find that it is 1.013. Okay, so you take this number and you divide it by 4 first, and then you add it to the 1. And then I'm going to simplify this part to 48. Then I use my calculator the way I did it earlier, and I enter 1.013 raised to the 48th power, and I should get this as the answer. And then I take that and multiply it by the original amount. And then this will give me $185,888.87. And that is an approximation, but only off by a little bit. Okay, so that should be the answer for this question. The last example I will be doing is the one on depreciation of the car. Okay, let's say you buy a brand new car at $32,000 and it depreciates at 12% each year. So the R is 0.12. However, this is the depreciation rate for the first 4 years. After 4 years, it's going to depreciate at a lower rate, 8%. So the question asks, what will be the value of the car after 6 years? So for 2 years, 6 minus 4, okay? So for 2 years, it will depreciate at this rate. But for the first 4 years, it will depreciate at this rate. Now we're going to use this formula. Y equals this, but minus the R, okay? That's the depreciation or decay question formula. So you start out with 32,000, 1 minus the rate of depreciation, and then raised to the 4th power, because for 4 years it will depreciate at that rate. Okay, then you find this, and then you end up with a new value. So this will be the value of your car after 4 years. And then it will depreciate, what I call a second round, okay, at 8%. Now it's going to depreciate with a new starting point, this new amount. Okay, that's what the value of the car is now after 4 years. But now it's going to depreciate at a slightly lower rate for only 2 years. And this will be the amount after 6 total years. Okay, so the conclusion is in 6 years, the value of the car went from $32,000 to $16,242.63, which means that it lost about half of its value in just 6 years. And this is one of the biggest costs of owning a car, is the loss in its value. Because once you pay that much money for that car and you drive it off the lot, it starts to depreciate. 12% is actually not a bad depreciation rate. Most cars depreciate even faster than that. In fact, I looked this up online to see what it's like right now. So if you were to buy a brand new Toyota Camry right now, the lowest priced Camry, okay, because the Camry comes in many different trims, different styles, so it ranges. This is probably the cheapest Camry you can buy. The higher end is around $36,000. Okay, so if you buy a Camry at this price and you wanted to trade it in, and I looked up the trading value, okay, after you drive it for about 5,000 miles, and if you wanted to sell it somewhere in California where my mom lives, okay, I entered in the address for my parents. This will be the price that you can trade it in for, $17,848. And I calculated the rate of depreciation of just 1 year. Okay, actually it hasn't even been a year, but after 5,000 miles. They actually calculate depreciation more on not just on years, but on how much you've driven it. 5,000 miles is not a lot at all, okay? It depreciates at about 26.9% per year. Okay, that is how quickly this car will lose its value every year. Now, this rate will not stay the same over the lifetime of the car. The depreciation rate does slow down, okay? It does get lower and lower as the car ages. So that's why it's much better to buy an old car. Buy a used car, because the depreciation, the bulk of the depreciation has been done already. So if you buy a car that's already 5-6 years old, most of its value that it was supposed to be lost has already been lost. So by the time you buy it, it's already at a much lower rate, a much lower cost. It will continue to depreciate, but not at the same rate as before, so you don't lose as much money when you try to sell it. Okay, so you can see that in a exponential decay graph, most of the loss, see, it goes down most quickly at the beginning. Okay, and then it kind of like peters out. It kind of slows down. The rate of loss slows down here. Okay, so, but it's already pretty low. You see, it loses a lot at the beginning, and then it gets pretty low, but then it slows down its loss. Okay, so this is a very important lesson. I hope you learned from this particular problem, is that the rate of depreciation for new cars is very, very high, actually. You lose, in this question alone, you will lose about half the value of a car in just 6 years.